My name is Kari Beckendorf. I am the Communications Specialist with LANDFIRE. In this short, I will share a new LANDFIRE improvement called Drought Based Fuel Dynamic methods for the Southeast United States. This work was performed by Charley Martin, the LANDFIRE Fuels team lead. Why the Drought Based Fuel Dynamic method? Fuel models were not always accurate in Southeast United States because they did not predict relevant fire behavior during drought or seasonably dry conditions. In an effort to improve the functionality of the fuel products, LANDFIRE proposed using the drought-based fuel dynamic system. The system is comprised of three main components. The first addresses additive fuel weight by size class and fuel bed depth as drought increments increases. The National Fire Danger Rating System was used to suggest weight and depth for severe drought, and then those fuel models were correlated with their additional fuel load and depth to the Fire Behavior Fuel Model 40 layers. The second component addresses vegetation type. As fuel models are transitioned, vegetation type helps determine which transition might occur. The final component addresses drought increments. The Keach-Byram Drought Index is subdivided into 4 equal increments. KBDI outputs for the Southeast were intersected with the fuel model transition table and then were transitioned to either the same, similar, or more aggressive fuel models, depending on existing vegetation type and drought class. We used a spatial version of the Nexus Fire Behavior Processor to produce maps of several fire behavior characteristics at 30 meter pixels for each of the drought classes using the Fire Behavior Fuel Model layer that corresponds to the drought level. Note the gradual color change in the fire behavior from blues and greens in the no drought and low drought levels to more yellows and reds in the moderate and severe drought levels. To test the method, we analyzed the Bugaboo Swamp Fire, first detected on May 7, 2007 in the Okefenokee National Wildlife Refuge. We used the FireSight program to simulate the first 2 days of significant fire spread. Due to gusty wind conditions, the fire spread 11.7 miles on the second day, May 8th. Modeling the Bugaboo Fire shows how drought-based fuel dynamic methods define fuel model transitions for swamp areas. When we compared standard LANDFIRE 2012 model layers to the severe drought fuel model layers, one replicated the way the fire behaved, but the other did not. By using the drought-based fuel dynamic method, the landscape was transitioned to a shrub model that more favorably represented actual fire behavior. In closing, the key messages are: first, fuel models are not always accurate in the Southeast United States in a static fuel model system. Second, the drought-based fuel dynamic system has 3 components: additive fuel weight by size class and fuel bed depth, vegetation type, which influences fuel model transitions, and drought increments, which are applied to the transitions. Third, the system was created to adjust fuel models based on environmental conditions, in this case, drought. And fourth, the method improved the fuel product's functionality.